Well, believe it or not, lesson number 5, we are still looking at surface area, this time of right cones. And surprise, surprise, just like always, we're going to be looking for the lateral area, and we'll be looking at the area of the base. Cone only has two pieces. It's got a base, and it's got a lateral surface. We'll be playing with the radius of the base, which will be the radius of the cone, and we'll be playing with the slant height. All right, bunch of vocabulary there. Let's replay this again and again if you're really excited about learning what all those wonderful words mean. What we will not be working with is an oblique cone. Right? Surface area of an oblique cone is very tricky. So just like we've done with most of our three-dimensional objects, we'll be taking a look at just the right cone. Again, the slant height is the distance between the vertex and a point on the edge of the base. All right, because it's a circle, doesn't matter where you go down, they're all going to be the same. Because the vertex is directly above the center of that circle. An oblique cone does not have a slant height because depending on how you try to go from the vertex to the edge of the circular base, you'll get very different answers there. So again, the two key things we need to know the radius, we need to know the slant height. The lateral area, pi times the radius times the slant height. The surface area will be the area of the base plus the lateral area. So I remember area of a circle is pi r squared, so area of the base is pi r squared. Then the lateral area will be pi times r times the slant height. Notice it's not 2 pi r times the slant height. You're thinking, hey, wait a minute, shouldn't the circumference of the circle be 2 pi r? Yes, but we don't have a cylinder, we have a cone. And so we end up having to multiply by 1/2, because you can kind of think of the cone as being very related to a triangle. And so when we do the 1/2, that will cancel out the 2. All right, just for fun, I thought maybe we'd take a look at a cone that appears to be upside down. Instead, I think a cone that's ready for some ice cream to be scooped into it. We're not given the slant height, right? I've got the height of the cone as 8. I got the radius of the base as 6, but I don't have the slant height. So a little bit of magic with the Pythagorean theorem. You should be super acquainted with that by now. I should be able to come up with 10 for my slant height. So if the lateral area is pi times r times L, I'll go pi times 6 times 10. Lateral area, 60 pi. Area of the base, pi r squared because it's a circle. Pi times 6 squared, well, 6 times 6 is 36. So the surface area is the area of the base plus the lateral area. Again, just like the pyramid, there's only one base. So if I'm happy with an exact answer, 96 pi is an exact answer. If instead I'd like a decimal equivalent, I can multiply by pi. And I end up with 301.59. And again, on the very last step, when I proclaim my answer, I need to put the label of square meters. Now, for just a moment, I want to do a little bit of comparison. Think about that regular pyramid, 1/2 times the perimeter times the slant height. The right cone, the lateral area, was just pi times r times the slant height. Of course, for a circle, perimeter is the circumference. Circumference being 2 times pi times r. So if we substitute circumference for the perimeter, right? Thinking about my regular pyramid again here, 1/2 times the perimeter times the slant height. Substitute circumference for perimeter, because the circumference of the circle is basically the perimeter of the circle. 2 times pi times r for the circumference. Sure enough, the 1/2 and the 2 cancel. I get pi RL. So yeah, the lateral area of the pyramid, the regular pyramid, and the right cone are basically the exact same thing. 1/2 times the perimeter times the slant height. Okay, so again, let's do one more example here. Surface area of the right cone. Oh boy, I don't know the radius of the circle. Thank goodness for the Pythagorean theorem coming to my rescue yet again. So the radius squared plus the square root of 7 squared will have to equal 4 squared, because 4 is the hypotenuse. Of course, the square root of 7 squared is just going to be 7. 4 squared is 16. Don't go into autopilot and add the 16 and the 7. That's why I like to write things down and show step-by-step work. Because if I show step-by-step work, I'll realize, whoa, I need to subtract 7 from 16 and get 9. Then, of course, I can take the square root. Radius is 3. So now we're set. Lateral area, pi times r times L. Radius is 3, slant height is 4. 3 times 4, of course, is 12. Area of the base, well, circle always has an area of pi r squared. Pi times 3 squared, so that's 9 pi. Surface area, of course, is area of the base plus the lateral area. 9 pi plus 12 pi, 21 pi. Hey, the picture does not have any label. I don't know if I'm dealing with feet or inches or centimeters or angstroms or miles. So I have to put square units because I don't know what the units are. And then again, I can use my pi button on my calculator, or I can use 3.14 with my calculator if I want to try to get in a decimal approximation instead of an exact answer. IXL today, if you are a person that likes to stimulate your visual learning, I think you might have fun with this one. Cross sections of three-dimensional figures. I think it'll be a lot easier for you to understand it by looking at the IXL questions and then have me try and explain it. So we've got a worksheet which will be looking at the surface area of right cones, and then the IXL, it's a little bit different. You'll have fun with it, I bet.